this video, I'll be making iodine crystals. Iodine is a halogen situated between bromine and astatine on the periodic table. To do this, you'll need copper sulfate, calcium chloride, potassium iodide, and some sodium thiosulfate. First, I'm putting in around 2 grams of copper sulfate. Now I'm getting some calcium chloride, and I'm putting in around 3 grams of that. By the way, if you decide to do this on a larger scale, you can always double or even triple everything that I'm using. I'm getting some potassium iodide now, and I put in about 1 gram. I got a hot plate, and I put the mixture onto it, and I also put a plastic cup in with some ice water. If you do this yourself, try to find a cup that fits the beaker pretty well, because you don't want too much of the gaseous iodine getting out since it's toxic. Already you can see some purple gas forming and the mixture is turning a brownish color. There's also lots of crystals forming on the sides. All of this is because the copper sulfate is reacting with the potassium iodide in a double exchange reaction, and it's producing some copper iodide and potassium sulfate, as well as some iodine, which comes off as the purple gas. Just now I put in some copper sulfate and potassium iodide to keep the reaction going. I also put in that calcium chloride because it's hygroscopic and will act as a desiccant, just to make sure that there's not too much moisture that could suck up the iodine and, mess up the reaction. Anyway, after the double replacement reaction between the copper sulfate and the potassium iodide that produce the diatomic iodine, the heat causes it to become a gas, and that's all the purple stuff that you saw before. It should be coming back soon. So then the iodine gas goes up, and when it comes into contact with the cold surface of the plastic cup that I had the ice water in, it will condense into a solid and it will crystallize. So that's what all the gray crystals on the plastic cup are. After I put in some more copper sulfate and potassium iodide, you can see some gaseous purple iodine coming back, so it should also be forming crystals. Hopefully not too much of it is coming out of the beaker and into the air. Unfortunately, some moisture did condense in the upper part of the beaker where there's no calcium chloride to absorb it, but it didn't seem to mess things up too much. Once enough crystals had accumulated, I removed our setup from the heat. Now I'm pouring all the cold water back into the beaker, and I'm putting in some sodium thiosulfate, which should neutralize all of the leftover iodine. Now we have some nice iodine crystals. I put it into a plastic petri dish, and as you can see, some of it diffused through. So if you do this yourself, maybe use something other than plastic to store it in. Thanks for watching.